All right, let's make sure I'm recording, and I am. Don't want to forget that. Okay, here we go. I think the last thing we talked about is regular polygons, didn't we? Did you write that down? Equilateral, equiangular, and then regular? Yeah. And did we do diagonals? No. We didn't do diagonals? Okay, let's do diagonals. Let me show you what a diagonal is. Let's go to this and go to this. I don't know if I showed you this tool that I have on this program or not, but okay. Have I shown you that before? Did I do that before? Yes. Oh my gosh. Go ahead. Do you have your book? All right, let's do this. What kind of gon is this? What kind of polygon is this? If I asked you, because this could very easily be a question on a quiz. Okay, I could wait. Let me. I know, but let me finish. All right, I already heard you say it. It's a hexagon, but what I was trying to say is, what kind of polygon is this? This could be a style of question that would be on the quiz or a test. All right, so I could just give you a picture, and you have to identify or classify is what I would probably say on there. I would say classify each of these polygons. What does that mean to classify it? Name it by how many sides it has. All right, that's basically what that means. Jason, question? Okay. So what we're going to do right here is we're going to show you what a diagonal is. You can start at any of these points. There's a word that we've already learned about what the name of those points, where those two endpoints come together. We have a special name for that. What do we call it? Call it a vertex, okay? So we could start at any vertex that you want. It doesn't matter which vertex you start at. Let's just start right here. What we're going to do is we're going to draw a line segment from one vertex to the other. But when I say that, you can't draw one to the one that's right next to it. You with me on that? Okay, so I can't draw it to here, and I can't draw it to here. So I got to go like through the polygon, all right? So I want to see how many vertices, that's the plural of vertex. I think I talked about that, didn't I? The plural of vertex is vertices. So how many diagonals can I draw? Well, I can draw from here to here. That would be considered one diagonal. Everybody got it? Okay, from that point, from that particular vertex. I could draw another one. I could go from here to there. All right? And how many more could I draw from this point right here? Just one more. I could go to here. These are called non-consecutive vertices. So when I say, if I'm talking about this vertex right here, this vertex would be next to this one. Do you see it? Because it attaches to it. Anybody looking? I got a lot of heads down. Let's everybody look up here. So this point right here, this vertex, is right next to this vertex. This one right here. Everybody see it? That's right next to it. So those would be considered consecutive vertices. All right? They're right next to each other. They're consecutive, one after another. Make sense? This one would be a non-consecutive because it's not right after it. You got to go to this one, then you got to skip over to this one. This would be a non-consecutive vertex. So how many sides do I have on this polygon? 1, 2, 3, 4, 5, 6. Okay? So there's 6 sides. Oops. There we go. 6 sides. How many diagonals? From one vertex, how many diagonals can I draw? Look, I've drawn them. They're in red. How many? 3. Only one person knows? Okay, there's three diagonals. Remember, the red lines right here, the red line segments, they're diagonals. Okay, so there's 3 diagonals. I thought we were clear on this. No? All right, there's 3 lines here. That means there's 3 diagonals. Okay, let me show you something. Oops, I got to spell it right. Diagonals. Is there going to be 3 diagonals for every single polygon that you ever draw? No. All right. What we're going to do is do a couple more, and then I want to figure out how many diagonals. And then we want to figure out, is there a rule? Is there a pattern going on with this? So let me move this up a little bit, and let's go back to white on this, and let's draw another polygon. but I'm going to change the number of sides if I remember how to do this. I think it's shape, and then I can change, where is it? I thought it was shape. Oh, there it is right there. I had it covered up. I don't know. Let's go like 8 sides. Let's go 8 sides. So what's an 8-sided polygon called? That's an octagon. So let's do this. Let's draw some diagonals just from one vertex, okay? We're not going to draw them from all the vertices, just from one vertex. Let's find out how many diagonals we have on 8 sides. So let's start, I don't know, let's not start at the same spot. Let's start down here, just be different, okay? Now, I don't draw to here because that's a consecutive vertex, right? Where do I draw? I draw up to there, okay? And then draw another one to there. Are you with me on what a diagonal is now? Again, we're starting from the same vertex. Go to there. Go to there. And how many more do we have? Just one more, right? And it goes to there, okay? So let's write this down. How many sides do we have now? How many sides? We have 8 sides. How many diagonals do we have? We have 5 diagonals. I could do this one more time, but I'm not going to. What do you think? Usually just doing it one time isn't enough to establish a pattern, okay? But if we do it some more, you're going to find this pattern going on. So what did we say when I had 6 sides? We had what? 3 diagonals. When I have 8 sides, I have 5 diagonals. What do you think the pattern is? Odd numbers? No, not just odd numbers. 3 less. Very good. It's 3 less, okay? So no matter how many sides you have, what if you had 12 sides? How many diagonals could you draw from one vertex? 9 diagonals. Are you with me on that? Okay. So I think there's a question in the homework, I think there is, where it says something about that. It says something about if you have so many sides, how many diagonals are you going to have? All right. Now, that's diagonals just from one point. What?
How would you label it? Would you just write the...
Well, if I name this A, B, C, D, E, F, this is called hexagon A, B, C, D, E, F, right? We've talked about that before. If I wanted to name the diagonals, I would just name them by the line segments. So what's this first diagonal right here? Line segment what? AC. Then what? Line segment AD, line segment AE. All right? That's how you would name them. Let me ask you this. Let's think a little bit more on this one, because this is really what they ask. I think it's a homework problem. I know I saw it somewhere. We did like a little review with my honors class. I can't remember if it was on that review sheet or if it was on the homework. I can't remember. But what if I asked you how many diagonals can be drawn all together from each vertex? So there's 3 from this one vertex. How many from this vertex? How many diagonals could I draw from here? Okay, how many? Give me a number. 3. How many can I draw from here? 3. Keep going. 3, 3, 3. So how many diagonals can be drawn all together from every single vertex? It'd be 3 times what? 6. Where'd the 3 come from? Well, it's 6 sides, so you're going to have 3 diagonals, right? And if you can draw 3 diagonals from every single point, and how many points are there? 6 of them, right? 3 diagonals, there's 6 points. So how many total diagonals can I draw? I can draw 18, okay? I'm not going to get too far into this next part, but I want you to see this. How many triangles were formed from drawing my diagonals just from point A? 4. You said it right the first time. There's 4. 1. That's 1. That's 2. This one's 3. Wayne, turn around. This is 4. Do you see the 4 triangles? See, ABC, ACD, ADE, AEF, right? I'll tell you what. I think you can handle this. How many degrees, and I don't know if we've talked about this year, but I know you've talked about it in your middle school math classes. How many degrees in a triangle altogether? One triangle has how many degrees? 180 degrees, right? You learned that, didn't you? See? You asked, it was like you were asking me if it was 180. So you knew it. It's in your head. So you learned it at some point. So listen, one triangle, that's the symbol for triangle right there, is 180 degrees, right? Let me ask you this. I want to find out all the angles, the sum. What does that mean, the sum? If you do what to it? Add it all together, okay? If I added up all these angles, angle A, angle B, C, D, E, F, if I wanted to add up all the angles, okay? Haley, you watching? You getting all this? Yeah, that's kind of hard with your eyes closed. So get your head up, please. Get your head up. Everybody's going to have their head up. Nobody's going to have their head down. Jaheim, you promised me like 5 minutes ago, but your eyes are closed. I don't care if you're sleeping or not. If your eyes are closed, I want you to look up here. I want you to look up here. There's nothing in your book to see with what I'm doing right here. Look up here. Your book's not even open. So look, if I asked you the degrees for all these triangles, one triangle is 180 degrees. There's 4 triangles in there. So talk to me. I got 4 what? Yeah, 4 triangles, but I want to find out all the angles, what all the angles add up to be. So it's 4 times 180. Anybody know what 4 times 180 is? No, you don't need a calculator. It's 720. All right. Shh. All right, guys. Listen up now. If you want to do this in your head, you probably could. What's 180 times 2? You should know that. 360, okay? Well, that's 2 180s, and another 360 would be another 2 180s, right? And so can you do 360 and 360 in your head? What's 36 times or plus 36? 72. So there's your 720. So you could do that in your head, couldn't you? Okay. But if you needed a calculator. So what does that mean? Listen, up here. No. Stop. I just want you to be quiet. That's all I want. I don't want an explanation. I do not want an explanation. Logan? I don't want an explanation. I just want you to listen to me. So if all of these angles, or all these triangles, add up to 720, that means all these angles right here add up to what? We just did it. 720, okay? So all these angles also add up to 720 degrees, okay? Now, let's think about this. The last thing we talked about yesterday, Nico, up here. The last thing we talked about yesterday was a regular polygon. This right here is a regular polygon, which means 2 things. All the sides are equal, and what's important here is all the angles are also equal to each other. Now let's think. If all the angles add up to be 720, and all the angles, A, B, C, D, E, F, are all exactly the same, could I find how much each of these angles is? How do I do it?
Divide it
by
6.
Very good. So I take 720, that's what they all add up to. There's 6 angles here, right? And they're all exactly the same. So if I divide it evenly by 6, that should tell me what each of these angles actually is. So what's 720 divided by 6? Well, what's 72 divided by 6? That's 12. And then you do what? Stick a 0 on the end. So that means that every single one of these angles is 120 degrees. All right? So without even giving you any like math on here at all I told you was it's a regular hexagon, okay? A regular 6-sided figure. You should be able to figure out what each of the angles of that hexagon is equal to. I think that's kind of cool. So there you go. Let's do this real quick. Let me just draw. Oh, I got a triangle here. I'll just use one of these. Let's use this one. Okay. I just want to describe a word because we're going to deal with it here in a minute. So let's just label this. We'll call it ABC. Okay. And so that's angle A, angle B, angle C. If I asked you, here's the word we're going to use. It's really not that hard. but it's something that we use a lot later on in the year. We use it over and over and over again, right? So now's the first time we're going to see it, okay? So if I talk about opposite angles or opposite sides, so if I took a look at angle A, and if I asked you what the opposite side of angle A is, take a look at it. What do you think? What is it? It's B. That's a side. If I just said B, say it correctly. Very good. That's exactly what I wanted to hear, okay? It's line segment BC. Because here's this angle. Look what's opposite. See this angle A? This part touches A. This part touches A. Which part does not touch A? BC. Line segment BC. So I would say that line segment BC is opposite, I'll just shorthand it, of what? We're not just going to say A, we're going to say angle A. All right? AC? No, because A, listen, it's a good question, but listen. I'm waiting. I don't need that. So if you look at this, the side that's opposite is the side that does not contain that vertex A. Does AC contain the vertex A? Yeah, it does. So AC cannot be opposite. Look at AB. Does AB, line segment AB, contain point A? It does. But does BC contain point A? No. So BC must be opposite of angle A. You don't say that line segments are opposite other line segments. You only say that angles are opposite line segments or line segments are opposite angles. It's a good question. Okay? What if I did this? What if I talked about angle B? And I asked you which line segment, because this could be a quiz question or a test question. If I asked you what line segment is opposite angle B? All right, Rosalind, give me another shot.
Line segment AC.
Very good. So we would say that line segment AC is opposite angle B. We could go the other way too, right? I could give you a line segment and ask you what angle is opposite. I keep getting all these texts. What in the world? Okay. All right. Let's do the last one. So angle C. Now if these angles are not equal to each other, that's got one arc. This has two. How many would I put here?
3.
Good call. All right, so 3. So I would say what line segment is opposite of angle C? What line segment is opposite angle C? Which line segment doesn't have C in it? AB, that's right, line segment AB. So line segment AB is opposite. Again, this could be a great quiz question, okay? I could very easily give you something like this. So I hope you're paying attention. So it's opposite angle C. I could go both ways. Remember, I could give you a picture. I could number it. Okay? I could change the letters. Okay? I could change the letters and all that kind of stuff. Sometimes I like to do this. Sometimes I like to draw an arrow just to indicate what's opposite. Here's angle A. That would be opposite, wouldn't it? Okay, here's B. This side right here would be opposite of B. Here's angle C. This side right here is opposite angle C. All right, if you want to look at that way, you can. This is a very important word that we're going to use over and over again, okay? We're going to do a lot more with stuff being opposite later on, but it's important that we understand that right now. All right, let's do another word. This is a word that you probably heard again in middle school, and it is called perimeter.
I know what that is.
Okay?
That's like all of the length.
Okay, this is how I say it. I just use 2 words. You could, and what you guys said was absolutely right. Okay, I say it like this. The perimeter is the distance around. Okay? It's the distance around an object. Okay? So if I wanted to find out the perimeter of something, okay, I would go around the object and measure that distance. Okay, again, this is very important. You're going to do a ton of this stuff later on. All right? But we're just kind of scratching the surface right now with perimeter. It's the distance around an object. So let's, I'm Let me do one of those polygons again. Yes. All right, what if I said this? What if I said this was a regular polygon? This could be a quiz question, so watch. If I said this was a regular polygon and I said that length was 5 inches, and I asked you to find the perimeter, okay? P is for perimeter. I put a question mark because that's what we're trying to find, okay? Remember, I have to tell you that this is a regular polygon. If I only give you one side, I have to tell you that it's a regular polygon. So Jason, help me out. That's exactly right, okay? You'll go 5 times the amount of sides, all right? Or if you wanted to, I don't know why you'd want to, but you could say, oh, if it's regular, then that's 5, 5, 5, 5. But that's too much work. It's too extra, as the kids, I don't know, do you still say that? People used to say extra all the time. I don't know. Anyway, I never did. The kids did. You say what? Okay, I won't. I will, believe me. I try my best to ignore him, so that's fine. Thanks. All right, so I like Jason's idea better, is if each side is 5, let's find out how many sides we have, because we know that all the sides are exactly equal to each other, so let's count them up. 1, 2, 3, 4, 5, 6. There's 6 sides. Each side is 5, so what's our perimeter? Now, I left them out on these other ones, but I did put something here. Right, that's right. These are our units. We call these the units. Let's not shout out. I know you're so excited about perimeter, okay? But we're all shouting out. Just wait a minute. Just wait until everybody calms down, then I'll get you. Just wait. Just wait. Just wait. Just wait. All right, he had his question first. I will. Question, Rosalind? Okay. So I will. All right. If I ask for the perimeter and if I give you inches or centimeters or feet or miles or whatever it is, whatever the units are, you must, okay, put those units right here. Okay. And I will take off for that. Is everybody listening to me? So you can't come whining and crying to me. Mr. Hamrick, I got the problem right. All I did was forget to put inches there. Well, you know what I'm going to say? Remember at 1:27 on September, 22nd? I said that I will take points off, okay, if you don't put the units. So there it is. That's how you do it. Pretty simple. What about if we had something where you didn't have like straight sides like there, right here, and you couldn't add them all up? I'll tell you what, let's do another one first. Before we get to what I was going to talk about, let's do this first. What if I had this, okay? And I told you it was a rectangle. You can't just assume that it's a rectangle, but I tell you that it's a rectangle. Or I could do this. I could put a little box right there. What does that little box mean? It means it's 90 degrees, which means this is a rectangle, okay? It is a right angle, correct. All right, come on. I know you're excited to answer, but just wait until I do something here. So what if I said that was 7 and that was 3, and that's all I told you, but then I asked you, what is the perimeter? John, what would you do?
You could do 7 times 7.
7 times 7?
No. 7 plus 7.
Okay, where'd you get the other? Yeah, this is going to be 7. If it's a rectangle, these opposite sides are the same, aren't they? Okay? And then, keep going, John. If this is 3, then what? Then this is a 3 as well. All right, so now, I hope everybody's watching. So now, in order to find the perimeter of this, you find the distance around it. So you just add up all the sides, right? What's the easiest way to do this? 7 plus 7 or 7 times 2, right? Either way you want to do it. Okay? I'm going to do it like this. I'm going to show you in a second why. Okay, watch. 2 times 7. You could do that, correct? It'll give you those two. And you could go what? 2 times 3. All right? So what's 2 times 7? What's 2 times 3? So what's your perimeter? It's 20. Now, I didn't put any units here. So if I didn't put any units, do you have to put units down? Not if I didn't, okay? But what if I said this was in centimeters? And this was in centimeters. Then this would be in centimeters. Okay? All right? Now, the reason I did this is because you'll see some books, and I think this book does too. They're going to give you like a formula for perimeter. I think it's kind of silly to give you a formula for perimeter. I understand why they do it. But in order to find it, in order to find the perimeter, I just realized that you're just trying to find the distance around it, right? So you just add up all the sides, okay? But sometimes they do this. Sometimes they'll call this side the length, okay? And sometimes they'll call this side the what? The width. Or L and W, right? So you'll see sometimes the perimeter formula written like this. You'll see what? 2, what do you think? Look what we did here. Right, 2 times the length plus, keep going, plus 2 times the width. You may have seen this before. Some teachers will just say, here's the formula for perimeter of a rectangle, just learn it. But to tell you the truth, I would not make you memorize this. I would just understand that when you find the perimeter of a rectangle, you just add up all the sides. That's all you have to do, okay? It's way easier than a lot of teachers make it, tell you the truth. Okay, now we're going to get to something. Trent, did you have a question?
Yeah.
What is it?
Breezy snoring is like distracting.
Well, that's all right. Block it out. He promised me. So that's Jaheim, by the way.
I call it breezy.
And Breezy, better known as Breezy. He's sleeping in my class after he promised me that he would not sleep in my class. So, is it a sin?
Breezy, is that a broken promise?
Sounds like it. He's not going to answer because he's not currently with us right now. So, all right, let's take a look at this.
He's on a different plane. You know, he's like a different plane.
I do see what you did. Yes, very good. All right, let's take a look at this. What if I asked you, listen now, we're going off on a different one now. What if I ask you to find the perimeter of this thing? It is a circle, correct? Yes, very good. So we don't usually say, the perimeter of a circle. You could, that's fine. It just means the distance around it. But when we deal with circles, sometimes they give them special names, okay? So instead of calling the perimeter of a circle perimeter, we call it circumference. Okay, so that's the circumference. Now, with circumference, listen, with circumference, you do have to know a formula. There's no way around it. You're not just going to count up all the sides, because there are no sides to this. Would you agree? So we need a formula. Does anybody off the top of their head, without looking at the book, remember what it is? Makai, tell me. Yeah? That's it. You got it. But we usually write it like this. We usually write the 2 pi first and then the radius after it. But it's the same exact thing. And you're like, well, what in the world? Oops. What in the world is the radius? If I could click on this thing. All right. All right, watch. Oops. Tag on it. Yeah, but we're not going to today. We're just doing perimeter. All right, watch. So we'll call that R. That's the radius. What is the radius? It goes from the center of the circle to a point on the circle, okay? This line, this skinny line that goes in a circle, right, it's a circle, that's on the circle. What about a point here? I think we've talked about this. Have we talked about this before? Right, this would be inside the circle or the interior of the circle. This would be what? The exterior or outside the circle. But if it's right here, it's what? It's on the circle, okay? It's on the circle. Do you get the difference? This is in, this is out, this is on, all right? Interior, exterior, on the circle. So if I draw a line segment from the center of the circle to a point, any point on the circle, that would be the radius. What if I drew from the center here to a point over here on the circle? Well, pretend it hits, okay? I was a little short. Right there. Is that different than this? It is? Well, it's a different line segment, but is the length of it any different? No, it's not. So this would still be the radius, wouldn't it? I could keep doing this a million times, couldn't I? From the circle, from the center of the circle to a point on the circle. It would still be the radius. Okay, it's still the exact same number. Okay? Watch what I'm going to do, though, now. You guys use this word, so I'm going to, if I can grab the thing. Is that it? Yeah, it's it. Okay, now watch this. Shh, shh, shh. Look up here. So look, if I go from a point on the circle to another point on the circle, but that's something different. We're going to talk about that in a minute, okay? But if I go through the center of the circle, oh, my finger just cramped up. Gripping too tight, I guess, on this. Now watch, if I go from a point on the circle to another point on the circle, but I go through the center of the circle, what do we call it, Jason? Your dying answer. Tell me. Oh, go ahead.
Oh, my question.
Yeah.
Oh, so what's it called? So is there gonna be like some test questions where they like ask for like the approximate on the circumference?
We're going to talk about that in a second because I'm going to throw a number in here. So we'll do that in a second, okay? So watch. This is a radius. This is a radius. We have a special name. Listen, and I've heard some people already say it. What's the distance from one point to another but goes through the center of the circle? Okay? Okay, help me out again. We'll call that the diameter, okay? Let's get rid of that thing right there. And we call this the diameter. A lot of times we'll use a capital D to represent diameter, okay? Really doesn't matter, but most of the time they use a capital D. So there's another way that you could write the circumference. So most of the time we learn it 2 pi r, okay? It's pretty easy to remember. But you could also learn what this means. Twice the radius is what? Is the diameter. So you could call it pi times the diameter, okay? It's the same exact thing, though, isn't it? Because twice the radius is the diameter, right? So it doesn't make any difference. John? Gigi, what'd you say? Okay, let's keep going. We're running out of time. Let's talk about this crazy thing right there, pi. All right, it's pi. It's not P-I-E, okay? It's P-I. Where do we get? I know. You guys are so excited. I appreciate it, but just let's go a little slower here. So where does that word come from? Like, where is that? Is it Latin? It is Greek. Yes, it's a Greek letter. It's an actual letter of the Greek alphabet, okay? And it kind of looks like that. It's a little weird looking, but that looks like that's a pi. That's a Greek letter of the alphabet. And what we do is we represent it with a number. And what do we usually use? I've heard you guys say it already. 3.14. But it keeps on going, right? But it doesn't repeat. Listen, it keeps on going and it never ends, but it never repeats. There's a couple times in there where you might have two numbers that are the same next to each other. But then it just looks like it's random numbers. It looks like it. It's not, but it looks like it's random numbers. So I have it memorized to 3.14159. But if it keeps going, how do we represent that it keeps on going? ... Okay? I used to have, a long time ago, I used to have a poster. It was about this tall, but it would wrap around the room. Not all the way around, but about halfway around the room. And I don't know, it had like 70 or 80 decimal places to it, okay? But at the very end of that poster, it said ... I was teaching this to my college algebra class the other day, a few weeks ago, and Mr. Rao, I teach it in Mr. Rao's room, and of course he's a math teacher, and he showed me a mug that a student gave him, and it had pi, and it was really, really small, tiny point, and the numbers like wrapped around the mug all the way to the end. But what I did is I looked at the end of it, and it didn't have a ... And I told Mr. Rao, I said, Mr. Rao, your mug is wrong. He says, what? He says, it doesn't have a ... He says, oh, I never noticed that. So I told him to put a ... in there. I don't know if he did or not, but anyway, that's just being silly. But there's no reason, listen, there's no reason to go past really like the third, maybe the fourth decimal point, okay? Because we're measuring things. Just listen. Put your hands down. Just wait until I tell you this. Because we use this to measure things. Right now, we're measuring the distance around a circle. Am I able to measure something with a ruler or a tape measure or something like that up to like 5 decimal places? There's no way. There's no ruler that measures that accurately, okay? So that's why we usually stop at 3.14, okay? Because really anything much after that, it's unnecessary because we've already measured it very, very accurately if we go 2, maybe 3 decimal places, okay? That's why we just use 3.14. And by the way, I'm not going to put pi equals this. What do you think I'm going to put? I'm going to put a little squiggly. Do you remember what that means? Approximately, okay? It means approximately equal to. Very good. Why do I put approximately? Why didn't I just put equals? Because it keeps on going and it never ends. You never actually get exactly equal to pi, all right? Now, let me tell you this. I'm going to show you if you guys can handle this. Do you think you can handle this?
Yes.
Okay.
I can handle it.
So watch. What's that?
How did they find pi?
I'm glad you asked because that's exactly what I'm going to do right now. I'm going to show you how they got that number, okay? Has any teacher ever showed you that? Probably most teachers don't, okay? But I'm going to show you how to do it. Now, I used to. You guys would go ballistic if I even tried anything different in here. But anyway, this is what I used to do. When I was a full-time math teacher, I just, again, started after 10 years, got back into teaching this full-time. So I used to have a cardboard circle, okay? Okay, hand down. Let me finish this. I used to have a cardboard circle. Okay, it wasn't super big, but it was about this big like this. And then I had a piece of string, all right? So the cardboard's got some width to it, right? So I take the string and I wrap it around the circle. Why would I do that? Why would I take the string and wrap it around the circle? Because what are we trying to find? We're trying to find what? Circumference, aren't we? Aren't we trying to find circumference? So if I took a piece of string, wrapped it around the circle, and then stretched it out and did what to it? Measured it, I would find the circumference of the circle. Would you agree? So would you agree that you could measure the circumference? Yes. You could also measure something else. What's the other thing that we talked about? Let me find out where the center is. It's right there. I'll put a little dot right there. So I could also measure the diameter of the circle, couldn't I? Okay. So I could measure the circumference, right? So the circumference, I could measure it. I could get a number for that, right? And then I can measure the diameter. Okay? I could get a number for that. Guess what I could find then? If I know the circumference, then I could find what? What pi is actually equal to. Everybody just knows it's 3.14, but you have no idea where it comes from. It comes from this thing right here. So I could measure this, get some number, all right? I don't know, 30 point something, whatever. Okay, and then I could measure the diameter. And then if I wanted to get pi by itself, do you remember from algebra, how do I get that d over to the other side? No, it's not being added. How do I get rid of something if it's being multiplied? I divide it. So I divide both sides by d. So what is pi actually equal to? It's actually equal to the circumference divided by the diameter. Do you see that? So that's what pi is. You could do this to any circle. And I used to do this. I had these like little stacking cups. You know when you're a little kid, you had these little cups you stack. So I would take a big circle. So I would take a big circle. I'd measure the circumference, measure the diameter, and divide. And guess what I got? I got 3. Well, I never really got 3.14 exactly because it's a pretty inaccurate measurement. But I always got just a little bit more than 3. Okay, I got 3 point and then just a little bit. Okay, you follow me on this? So the circumference of a circle, listen, and I would measure a small cup, and then I would get the same exact thing. Now the circumference was different, right? It was smaller, but of course the diameter is going to be smaller too, isn't it? All right. So I measured the circumference, measured the diameter, right, and then divided, and I always got a number that was just a little bit more than 3. So think about it. The circumference, the distance around a circle, is just a little bit more than 3 times going straight across the circle. In fact, I'm unprepared. I should have had this prepared. But there's a verse in the Old Testament somewhere that people use to say that, look, math or or circumference is actually in the Bible. And it really is, because it says that they were talking about a lake, and they were talking about the distance across, or the distance around the lake was 3 times the distance across the lake. I can't remember. It was some obscure Old Testament verse in, I don't know, Deuteronomy or something like that we don't usually read that often, okay? But it's kind of cool, because even in the Bible, it says that the circumference is 3 times the diameter, all right? And I think that's kind of cool, all right? So, no, it's going to be all together. So you still have the homework. So tonight is this. I said I wasn't. I said I'm collecting it all together. No, just a minute ago I said I'm collecting it all together. Guys, listen to me. I said I'm collecting it all together. All right, so add this to it. Add this to it right here.